Welcome to By Excellence Tutorials with your one and only By Excellent tutor. Subscribe to our YouTube channel and Facebook page, By Excellent, for more of these videos. So before us we have a question under dynamics, which reads, you have been hired to help improve the material movement system at a manufacturing plant. Boxes containing 22 kilograms of tomato sauce in glass jars must slide from rest down a frictionless roller ramp to the loading dock, but they must not accelerate at a rate that exceeds 2.5 meters per square second because of safety concerns. Question A, what is the maximum angle of inclination of the ramp? Question B, if the vertical distance the ramp must span is 1.2 meters, with what speed will the boxes exit the bottom of the ramp? Question C, what is the normal force on a box as it moves down the ramp? So once you have such a question, the first thing that has to come in your mind is to draw a free body diagram. So I have drawn a free body diagram here to say, let this be the ramp, where these boxes, so this is a box, are sliding down here to a loading dock. So maybe here we might say maybe there's a truck here that is loading these boxes of sauce, tomato sauce. So these boxes has to slide down the dock. Now with the horizontal, this ramp is making an angle theta, that which we want to find. So if this is an angle of inclination, we must be able to resolve the weight of this box. So this is the weight of the box, and when it is resolved, because this is in 2 dimensions, we have a component of weight in the x, which is mg, mass times gravitational acceleration, times the sine angle. And then we have in the vertical, we are going to have weight, mass times gravitation acceleration, times the cosine of the angle of inclination. And then we've been taught to say this ramp is frictionless. So we are not going to have any other force like friction force. We don't have a friction force. So in the vertical, we are also going to have the normal force. This is the normal force that these boxes are going to have. So to answer question A now, where we are supposed to find the angle of inclination, so let's say solution. For question A, according to Newton's second law of motion, which states that the acceleration of the object is directly proportional to the net force acting on it, but inversely proportional to the mass or to its mass. So mathematically, Newton's second law of motion is written like that. So now, the summation of forces in the x must equal to mass times acceleration in the x. Now we are going to discover that this box is moving in the x direction, meaning the acceleration it's going to have is only in the x direction. Or this acceleration that we've been given 2.5 is just the same as the acceleration in the x, because in the y or in the vertical it's not going to have the acceleration here. The acceleration is 0 in the vertical, it's just moving in the y. So the forces acting in the x direction is just this force, the x component of the weight. So we have mg sine theta equal to mass times acceleration, and acceleration in the equation we've been given to be 2.5. And then we know we are going to take gravitational acceleration to be 9.81. So we are going to divide both sides by mg, even this side mg, and then these are going to cancel, and we're going to remain with sine theta equal to mass and mass goes 2.5 divided by g. So we are taking g is 9.81 meter per square second. So sine theta is equal to 2.5 over 9.81, and then sine theta, the inverse, sine inverse of, you punch on your calculator, 2.5 divided by 9.81, you get 0.254841998. Then when you punch the angle on your calculator, you're going to have theta equal to 14.8 degrees. And that's how you would have found the angle of inclination. So the maximum angle of inclination of the ramp is going to be 14.8 degrees.